Okay, we learned interquartile range. But actually, interquartile range is an important measure, but actually the most popular pairs of summary measures are mean and standard deviations, right? So what I wanted to say here is interquartile range usually pairs with the median, which are these two are mainly to handle the outliers. When you expect outliers, then the median and interquartile range could be a good alternatives to the mean and the standard deviation. So that's what I wanted to say. Anyhow, more important is the mean and standard deviation. So in this video, we are going to study the variance, standard deviation. Okay, so to define the standard deviation, I am going to define deviation first. Literally, the deviation is defined as just how much each observation deviates from the center. Okay, so it's easy, like so. And we are going to use the mean as the center. So when the center is given, then you can calculate the deviation in this way. So the ith observation, the data, ith data minus the mean. That's the deviation, right? So let's think about example like Honolulu's temperatures, of course, like made easy as a numerical example. So suppose that you observe 76 degrees in spring, 82 degrees in summer, 80 degrees in fall, 74 degrees in winter. You only have four temperatures, okay? And then first you calculate the mean, and then you calculate deviation. That's how you calculate the deviation. So mean is easy to calculate. The average of these four numbers, and if you do calculate, it is 78 degrees. Okay, and then deviation is defined like this. Okay, right? So spring is 76 degrees, which is 2 degrees below the mean. And summer is 82 degrees. That means 4 degrees above the mean, right? Plus 2 means 2 degrees above the mean. It is 4 degrees below the mean. So, like, deviation only captures the relative distance from the center, right? And also, the point here is we have 4 observations of temperature, then we are going to have the same number of deviations. Okay, so here we are going to treat the deviation as a new random variable or just new data. When you have like million observations, then you can calculate a million deviations. That's how we are going to understand the deviation. So it is pretty simple. And the problem here is it is relative position, location from the center, but the problem is we do not need the sign, right? Plus 4 and minus 4 are basically equally distant from the center. So we are going to remove the signs by taking squares, right? So we define squared deviations, right? Remember, the first tab is calculating mean, and second step we calculate deviation, and third step we will calculate squared deviations, right? So minus 2 plus 4 plus 2 minus 4 becomes their squares, right? Squares. Very straightforward, and obviously after the square everything will become positive. So, and also the square deviation is the distance from the center. It is squared distance, but anyhow, the farther, the larger the square deviation is. So it is a distance. And also, we have as many square deviations as the original sample, right? As I said, when you have 1 million observations, you can calculate 1 million deviations, and then you can calculate 1 million squared deviations for each observation. And then we are going to define variance as the mean of the square deviations. That's the variance, all right? So mathematically, we call it this way. Expected value of x minus x expected x, which is deviation and then square deviations, and that's expected value, okay? So this is the variance. You can interpret this as the expected squared distance from the center, right? Usually we denote it as sigma squared or s squared. The reason why we denote it as sigma squared is because sigma will be for standard deviation. Sigma or s will be used for standard deviation, so we are going to denote it as a square. So it is always non-negative, and it is always the greater the variance is, the more variation in the data. Okay. Then I will give you two like formulas, which is very confusing. I don't like it. So first, in general statistics, population variance is the hypothetical variance that you can calculate when you have unlimited observations. And the sample variance refers to the variance that you calculate from the sample, which is finite, right? But in this chapter, in the variance calculation, there are two different formulas. Population variance formula is using n as the denominator. So remember, like say when you calculate average of x, it's calculated as this way. So this is very natural. It is very natural form. So this much is here. So it is average of this guy, that is squared deviation. But when you calculate the variance, you may use n-1 instead, right? So again, this much is a kind of average, and this is square deviation. So average of square deviation is the same. Basically, that is the same definition, but you use different formulas. If you ask me, well, like for example, like in our example, numerical example, we calculated squared deviations already, and then the final step is to calculate the mean of the squared deviations. But it depends on the formula you use, right? So there are 4 samples, like n is 4, sample size is 4, but you may use 4 in the denominator or 3 in the denominator. So of course the result is different, obviously. So here then the y. So that will come up again in chapter 8. But simply speaking, the idea is when you calculate this part, so remember, to calculate, you have to calculate the mean, and you have to calculate deviation, and then you calculate square deviations, and then you calculate mean of squared deviations. This is how you calculate the variance. The problem here is we start from sample size n, but when you calculate the mean, you consume one information. That is the idea, right? So statistically, it makes sense, right? So like in the first step, we lose one information, and so at the last step, basically the effective sample size is n-1 because we already calculated, we consumed one information in a previous step. So I will explain that in more detail in chapter 8. Okay. So this is what I just explained. Calculate the mean first and subtract the mean, that is deviation, calculate deviations, and then square the deviations, that is square deviations, and then sum, and then divide by or n minus 1. And also, if you ask me which is a more common formula, I would say sample variance formula is more common, right? So when you have to use just one of them, then I suggest using sample variance formula. Also, if you ask me what do you have to use for the quiz or for the exam, then the answer is I will specify that. I will specify whether you use sample variance or like population variance. So don't worry too much about quiz or exam. Here now it's your exercise. Let's try this. Calculate the sample variance for Phoenix, Arizona with different like these numbers. Also, there are 4 numbers. So you stop the video and try these numbers. I will do it here. So the 4 numbers are just, I will just call them X: 73, 95, 77, and 55. We got 4 numbers. Step 1, you calculate the mean. Mean is 73 plus 95 plus 77 plus 55 divided by 4. I already spoiled the answer. Then the average is 75. That's simple algebra, right? Also, I gave you the mean here to save you one step. And then let's calculate deviations. 73 minus 75 is minus 2. 73 is 2 degrees below 75, and it is plus 20 degrees. And this is plus 2 degrees, it's minus 20 degrees. Okay, and then I'm going to calculate, so second step has been done, it is deviation. Third step, squared deviations. Square the deviations, that is, minus 2 squared is 4, and 20 squared is 400, and 2 plus 2 becomes 4, minus 20 becomes 400. Okay, and the last step, we are going to calculate mean of the squared deviations. That is, we have 4 numbers, and we are going to calculate the mean. So that is sum 4 squared deviations and divide by 3 or 4, depending on the formula, but I told you to calculate sample variance. Calculate the sample variance, so you have to have 4 minus 1 in the denominator. So you calculate it, that is 808 divided by 3. How big is that? That is 269, right? So compare these to Honolulu's variance. Honolulu's sample variance was 13.33. So Phoenix is much like Phoenix weather is much more changing over a year. Okay, that's what we could learn from the variance. So we learned how to calculate the variance from raw data. I will continue in the next video.